Okay, here's a pretty typical triangulation question. All right, you're standing on an oval in Hawker and you're observing Telstra Tower. How far are you from the tower at position A? So I've drawn this really gorgeous picture of the Telstra Tower and I've given you position A and position B. Now it's obviously not to scale because this is 100 metres across here and we know that the Telstra Tower will be more than about a couple of 100 metres from us. All right, so you've stood at A and you've looked at the tower and you've determined the angle CAB, all right, which is 89.5 degrees. And you've stood at B, so you've walked 100 metres across the oval. You've stood here and you've worked out the angle CBA, which is 88.5 degrees. Now you've obviously got this 100 metres here as well. And I'm asking you, how far away are you from the tower if you're standing at A? So really what we're trying to work out here is this little length here. I'm going to call it B because I actually have angle B opposite it. It just makes it a bit easier to work with. Alright, and we can work with this one as well because it's the one that we actually have the known value for. So I would use this as our opposite. Alright, and because we have our angles and we have a side, we can use the sine rule. Now, one thing you're going to need before you can do this is, what's this angle up here? Angle C. Alright, now we know it's a triangle. We know triangles add up to 180 degrees. So we can do C degrees equals 180 degrees minus the 89.5 and minus the 88.5, excuse me for writing it downwards like that. Alright, and that comes to 2 degrees. Alright, so we know that this equals 2 degrees. So let's work it out. We've got our pairs of opposites, we've got our 100 metres and our 2 degrees, and we've got our unknown and our 88.5 degrees. Alright, so what we're going to do is we're going to do A over, or what is this? It's B and C, isn't it? So it's B over sine B equals C over sine C. Alright, now I've put the lengths on the top because we're trying to find a length, okay? If you're trying to find an angle, I put the angles on top. I'd literally flip it. So we're going to do it that way. So our B is just B. Our sine B is sine of 88.5, so we're going to write that down. Sine of 88.5. And our C is 100 metres, and our sine C is the 2 degrees. So it's sine of 2 degrees, like that. So B on its own would equal 100 times sine 88.5 over sine of 2. Alright, and that comes out to 2863 metres. It's obviously not a particularly accurate answer, but in the way of the actual physical distance, but it's the answer for this question. Okay, and then you can convert it to kilometres if that looks better. Okay.